Alright, so in the last video you got the four steps for solving by elimination, and in this one we're going to do three examples. What, Brenna? Example 1. 2x plus 5y equals 17, and 6x minus 5y equals negative 9. What was step 1? Okay, do both equations have x's and y's on the same side? Yes. Step 2? Eliminate an x or a y. In order to do that, you have to have a pair of opposites. Do we have a pair of opposites?
Yes, sir, we do.
Yes, the y's are opposite, so we're ready to add these together. And by doing that, we're going to eliminate y's. 2x plus 6x.
8x.
17 plus negative 9? 8. We're just adding straight down. 2x plus 6x is 8x. 5y plus negative 5y is 0y, so we don't have to write that because the y's are eliminated. Y's are gone. Yeah, if you want to, you go right ahead. And 17 plus negative 9 is 8. 8x equals 8. X equals? 1. So up here, I know that I've got one coordinate for the point of intersection. I've got x equals 1. Alright, what's step 3? Read your notes. What's it say? Solve for the variable that you didn't eliminate by using substitution. So we need to go back up to one of these equations, and it doesn't matter which one, and put 1 in for x. So do you want to use the top one or the second one? The top one. Okay, so that'll give us 2 times 1 plus 5y equals 17. Took the x out, put 1 in its place. It's 2 times 1. Subtract 2. You got to move the 2 over here and subtract it. So we're solving the equation for y now. 17 minus 2. Solve for y. That's step 4. Solve for y. Y equals 3. So the solution to this system of linear equations is 1, 3. That means they intersect at 1, 3. Now, if you tried to do this by graphing, you would get y equals negative 2/5 x plus 17/5. Would that be fun to graph? No. This one would give you y equals 6/5 x plus 9/5. Would that be fun to graph? No. If you want to use substitution, you'd have y equals negative 2/5 x plus 17/5 that you'd have to substitute into here, mess with those fractions. This is a lot easier. Alright. Example 2. X minus 3y equals 61, and 2x plus y equals negative 7. Yes, it says 61. Step 1, are they in standard form? Yes. Step 2, we have to eliminate an x or a y.
The y.
Now, can we eliminate the x's?
No, ma'am.
No. No, they're not opposite. Can we eliminate the y's?
Yeah.
No, they're not opposites. They have to be opposites. So what you have to do is ask yourself, do I want to eliminate the x's or eliminate the y's? Okay, if you want to eliminate the x's, these have to be opposite. So we're going to pick, just listen, we're going to pick one of these equations and multiply it by -1. If we multiply by -1, would we have a pair of opposites? Yeah, so I'll pick the top equation and multiply it by -1. So you multiply how many things by -1? 3. -1 times 2x is -2x. -1 times -3 is +3. And -1 times 61 is -61. Now do we have a pair of opposites?
Yes.
So we can add these together. The x's are eliminated. And we get 4y equals -68. X's are gone because when you add them, they make 0. Y equals -17. Make sure you put that in the Y spot. Now, if you follow the steps, we have to go back and solve for the remaining variable, which is x. So, which equation do you want to use, the first one or the second one?
First one. Second.
If you use the first one, you have to multiply by -3 first. It would be -3 times -17, and then subtract that from 61, then divide by 2. If you use the second one, you just plug in -17. So we're going to use the second one. 2x minus 17 equals -7. So I just took the y out, put -17 in. Solve for x. Add 17. What's -7 plus 17? Divide by 2. Got the x, we got the y, and we are done. They intersect at 5, -17. Alright, the final example. This will be example 3. And let me pick a problem here. How about (7x plus 8y equals 25) and 9x plus 10y equals 35. So what you're going to encounter are 3 different types of problems. In example 1, you already had a pair of opposites. In example 2, you had to multiply one equation to get a pair of opposites. And in example 3, you're going to have to multiply both equations by something to get a pair of opposites. So, first of all, step 1, yes, they're in standard form. Step 2, we have to eliminate a letter. Do you want to eliminate x's or y's? Y's? Doesn't matter to me. Y's? That's fine. Okay, 8 we can't multiply by anything to get 10. We don't want to use fractions. And 10 we can't multiply by anything to get 8. So you have to think about what the least common multiple for 8 and 10 is. The least common multiple, not the greatest common factor. What's the first number that 8 and 10 go into? There's a smaller one. 40? 8 times what is 40? So multiply this one by 5. That'll give us a positive 40. So here we need a negative 40. So multiply the second equation by what? Negative 4. So the first one by 5 will give us a 40. The second one by negative 4 will give us a negative 40. 5 times 7? 5 times 8? 5 times 35? Or 25? Negative 4 times 9? Negative 4 times 10? Negative 4 times 35? Negative 4 times 35? Negative 140. Do we have a pair of opposites? Yes, add negative 1x, y's are gone, equals 125 plus negative 140, negative 15. Divide both sides by negative 1. X equals 15. So we got the x coordinate, 15. Now we need the y. Doesn't matter which one you pick, first one or second one, your choice. First one. So what goes in for x? 15. 7 times 15 plus 8y equals 25. What's 7 times 15? 105 plus 8y equals 25. Subtract 105. Minus 105 is negative 80. Divide by 8. Negative 10. 15, negative 10.